Hello students, welcome back. Up to this point in our game, everything has been running frame by frame. That means the game speed is tied directly to the computer that is running it. On one machine, the game might feel absolutely perfect, but on another machine, it might feel too slow or too fast. And that lack of consistency is a really, really big problem for us. So in this lesson, we are going to fix it by introducing something called delta time, or DT. Delta time is going to let us measure actual time intervals, not frames. And so this is going to make our gameplay consistent across every computer. A super, super fast computer or a super, super slow computer, it will not matter. Our game is going to play the same, and that's exactly what we want. We're also going to introduce something known as a ramp, which is going to allow us to scale the difficulty of our game. So enemies might spawn faster or bullets move quicker. The gameplay will naturally evolve instead of feeling like it automatically jumps up in difficulty at some point. This should feel natural and enjoyable for our player. So by the end of this lesson, your game won't just run correctly. It's going to feel alive, scaling smoothly and consistently with every single second. So let's jump to our computer screen and let's dive right in. Okay, so I have lesson 5 open here, my starter file in vscode.dev. I'm going to minimize this really quick, and I'm going to go directly to where those files live, and I'm also going to open up the starter file so I have it in my browser. All right, so here we go. Okay, so you can see, what do we got here? Well, we've got some janky controls here. We are zooming all over the place. It looks like we've got something in our HUD here for time, but that's not moving at all. And our turrets are no longer operational. So we have, unfortunately, a broken game, and we need to fix it. But we know how we are going to fix it. We're going to go through and we're going to solve a bunch of missions together. Why don't we go take a look at our mission checklist right here. All right, lesson number 5, delta time and our difficulty ramp. Mission number 1, we want to add the delta time variable and clamp it. All right, so instead of just jumping to mission 1, let's just scroll through our code here, and let's just look at what is going on in our student edit zone for our gameplay constants. If we look here, we've got some comments next to certain specific variables. So player speed. I believe player speed in our last video was set to 5. That was 5 pixels every single frame. So we were using a frame-based system. So if your computer was slower, your player was going to move slower. If your computer was faster, your player was going to move faster. Now we've set it to 300, and that is going to be 300 pixels every single second. A second is the same on every computer, whether it's a fast computer, whether it is a slow computer. How did we get to this number? Well, if we are trying to move at 5 pixels per frame, and we assume our frame rate is 60 frames per second, we multiply 5 times 60, and we get our desired speed of 300 pixels every single second. And if we look, anything that involved calculating a value based on the number of frames, we've also converted. So our turret fire interval min and our turret fire interval max are also converted. They were previously 75 frames, fire at once every 75 frames and once every 105 frames. And we converted that to 1.25 seconds and 1.75 seconds. This time by dividing. 75 divided by our 60 frames per second gives us a time of 1.25 seconds. Also, it looks like we've commented out our projectile speed right here, and maybe that's probably why our projectiles aren't firing, because we're now placing it down here in the ramp that we are going to build in mission 5. But we'll get to mission 5 when it's time. The last thing we'll say is we've also changed our rate of draining for our overdrive. It was at 1.2 per frame, and moving to a time-based system, multiplying by 60 frames per second, that gives us 72. So we're going to lose 72 units of overdrive every second. All right, so that's a really nice look there at what is happening to our constants when we switch from a frame-based system to a time-based system. Also, in our gameplay variables, let's just look. We've got some new variables that we've defined. We defined something called runtime seconds. So if we look here, we're eventually going to keep track of how long the game has been running. We're probably going to use that variable here. We've got a ramp variable, which is currently 0, projectile speed, which is currently 0. Remember, we had commented that out before. And if you notice here, we're not making it a constant anymore. See, it was a constant before up here, meaning it was never going to change. But now we are defining it with let, which means we are implying its value will change. And that's going to happen because we're going to have a ramp that's going to speed our bullets up so they move faster and faster and faster as our game plays. The increase in difficulty is going to increase the enjoyment of our user. And we also have a variable called active turret count. We're probably going to have to keep track of how many turrets we are going to put on the screen. And when we start the game, it's going to be 0. All right, so let's head to mission number 1. Mission number 1 right here, our delta time setup, because the whole crux of this lesson is switching from a frame-based system, which is going to run inconsistently across various computers. Slow computers will be slow. Fast computers will be too fast. Right computers will be just right. But we want all computers to be right. So we're going to switch to a time-based system, because time is always the same. 1 second is 1 second is 1 second. And so we have a variable here, const dt, our delta time interval. And so what we're going to do is we are going to set this to, let's see, delta time divided by 1,000. Why are we dividing it by 1,000? Well, delta time gives us milliseconds since the last frame has occurred. So if you think about it, on a super fast computer, maybe the milliseconds is going to be really small. On a slower computer, maybe the time interval is going to be a little bit larger. But we don't want milliseconds, we want seconds. So we divide by 1,000 to convert milliseconds into seconds. So that looks pretty good. But we're going to do one extra thing here to protect us. We are going to clamp this value to prevent giant jumps, maybe during like lag spikes. So we want to give a small minimum value, because imagine if for some reason this value got super small, right? It got super small, then dt is going to be extremely small. We don't want that to happen. So we're going to call the min function when we're going to say, hey, grab the minimum of these two values. So I'm going to set a lower threshold of 0.033 and a maximum value of delta time divided by 1,000. So now if delta time gets super small, maybe like, I don't know, 0.001 seconds, we're not going to use it. We're going to use 0.033. And this is going to prevent any jumps in our gameplay. So this is just a nice little safety measure that we have. All right, mission 1, I believe we are done. We've created this delta time variable. So every frame, we're going to compute how much time has elapsed since the last frame that has occurred. Awesome. Let's look at mission number 2. Mission 2, runtime timer. We want to update the runtime timer using our delta time. And we're going to pass dt, that variable we just created, into our update functions that require time-based behavior. All right, so let's start with that first part of this mission. This mission's really got 2 parts to it. We're going to update our runtime variable. Remember, we had this runtime seconds, and if you look here, right now it is just clocked in at 0 seconds. We're not updating it. And that is because, look at what we're adding to it. Every single frame of our game, we're just adding 0. Well, that's really bad. We don't want to do that. We want to add, well, let's just see what happens if I add like, I don't know, 1 to it every single frame. All right, let's see. Whoa. Look at that. That's just going up super fast. Now, I do not think that our game has been played for 500 seconds right now. Our timing is absolutely not correct. So what we want to use is not 1. We're not going to add 1. That's a single frame, right? So right now, if you think about it, my game has been running and 900 frames has gone by. Not what we want. So what we're going to do is we're going to use our dt variable to actually get how much time has elapsed. And now, that is accurate time. So right now, my game has been played for 6 seconds. And that is 100% accurate, and that will be consistent across all computers, which is super nice. But now, we've got to do one other thing. We've got to pass this dt variable into other functions that are going to require it. Because if you look here, we are inside of a draw function, this function called draw. So when we define this variable, it only exists inside of this function. Only this function knows that the variable dt exists. And so if I go into another function, this function has no idea that that variable exists. Think of it like the draw function is a locked room, and this variable is stuck inside of that locked room. Other locked rooms have no idea what's in the other room. This is very different than our variables that are up here, our gameplay variables or our constant variables, which are not locked away inside of functions. They exist everywhere, and everybody, every function knows about them and can use them. So what we have to do is we have to pass in this variable to our functions that are going to need them. Some of these functions need to know about the time interval that has elapsed. And so let's think about the functions that are going to require time-based behavior. Well, we've got this new function called update ramp values. We haven't even looked at this yet. So let's not pass it in here. But our update player, are we going to need to know about our time-based behavior? Well, let's go to update player really quick. All right, update player. Oh, if you look here, update player now says, hey, I expect to get a dt variable. And I think that makes sense because if you think about it, we're going to move the player. We don't want to move this player every frame. We want to move that player based on time. So we're going to have to pass dt into our update player function. Ooh, we've got update overdrive. That needs dt because we are going to drain our overdrive system, not based on frames, but rather based on time. So we're going to need that. What else we got? Ooh, update turrets needs our DT because we're going to change. Look at that. We're changing our fire timer, not based on frames, but based on the amount of time that has elapsed. Update projectiles needs DT. Why do we need DT here? Oh, because if you look here, we're going to move our projectiles, and we don't want to move them based on frames. We want to move them based on our delta time. So I think that covers our ground. So let's go back to mission 2 now, and let's pass in this dt variable. So we said, hey, update player, we're going to give you that variable dt. Update overdrive, we're going to give you that variable dt. Update turrets, you're going to get that variable dt. And update projectiles, you're going to get that variable dt. Mission 2, complete. Well done, everyone. On to mission number 3. Well, let's just check. Can I do anything yet? Oh, my time is going, but I'm still wonky. Ooh, look, our bullets are somewhat firing. Are they following me? Yeah, they're moving way too slow, though. I mean, that's just broken. We got to fix that system. But before we fix that system, it looks like mission 3 has us fixing our wonky player movement. It tells us that we need to apply delta time to our player movement because right now the movement system is broken. We are going to ensure that the player's movement is consistent across different frame rates. And we're going to target these 2 lines right here. Now, we're going to head to the whiteboard because I want to teach you a pretty interesting relationship mathematically between 3 variables. Those variables are distance, time, and speed or velocity. And I'll say v bar, which is our average velocity. There's a known physics relationship that says, hey, if you want to figure out how fast something is moving, you're going to take the distance that it travels divided by the time interval, right? So if I went, let's just say 10 miles in 2 hours, 10 divided by 2 gives me my speed, which would be 5 miles per hour. All right, so that hopefully makes sense. But what we're going to do is we're going to take both sides and multiply by the variable t. And so when I multiply by t over here, those cancel, and I get this nice relationship for distance. How much we want to move is going to be our velocity times our time. And we're going to use this relationship. We're going to update the player's position, d, their distance, by looking at their speed and the direction that they want to move in, and then we're going to multiply by our time interval. What is the time interval we have here? It is that dt variable that we just passed in to the player's update function. All right, that's a little bit of physics. I love physics. That's good stuff. Now, let's head to the update player. We got the dt right here. We have distance. It's going to equal velocity. So the player's velocity is right here. Remember, this is the direction that they're moving, and then this is the size of that velocity. And look, it's set to be dt. It's our dt value, not our frame value of 5 anymore. And so what I need to do is I have to multiply by our time. I'm going to multiply by dt. So distance, boom, is equal to velocity, boom, times time, boom. Well, we should probably mimic that in the vertical direction because we want this to work in both the x and y directions. If we run this now, we should have smooth player movement. And that's much better. I'm imagining something is off with our bullet movement, and we probably have to implement this DT system there as well. And so let's head to mission number 4. All right, mission number 4, the halfway point. All right, now we are in update projectiles. Look at that. We have our DT, and we have to apply delta time to our projectiles movement. Hey, this is almost exactly the same as what we did to our player. Movement is movement. It doesn't matter if it's a player moving or a projectile moving. We have distance, and that distance is going to equal a velocity. Here's our velocity, projectile.vx, and then I need to multiply by time. And I got that time right here, our dt. And let's do that not only in the horizontal direction, but also in the vertical direction. Awesome. If I refresh this, we should have regular moving bullets now. Whoa! They are just completely stationary. So something changed. Something changed. Let's look at what our next mission is going to be. Mission number 5 says set the ramp constants. I think something is wrong here. Let's just see. Apply delta time to projectile movement. Yes, students, I apologize. We got ahead of ourselves. We fixed one problem, but there are underlying problems that we still need to solve. And so let's just highlight what the issue is. In mission number 4, I said, hey, let's update the player's x position by taking their x velocity and multiplying by dt. And if you look, it sort of looks like they are slowly moving outwards. Oh, sorry if that was mildly annoying. I'm trying to hit on the fact that we have the timing system in place, but we don't have the speed system in place. And here's the reason why. If I go way back up to the top of my code, if you remember, we got rid of the projectile speed being 4.5. And instead, right, we commented that line out. And instead, look at mission number 5, our ramp constants. We are going to set the ramp constants to control how quickly our difficulty increases over time. The speed of our projectile is not going to be set. It's not going to be clocked in at 4.5 pixels per frame. Instead, the speed of these projectiles is going to change as we play our game. They might start slow, and as our game goes on, they're going to move faster and faster and faster and faster, making our gameplay more challenging. We have not yet set the starting speed of the projectile and the ending speed of the projectile. That's why they're moving in super slow motion time. So let's do mission 5 right now. Let's adjust our ramp values. Now, let's talk a little bit about what this ramp is going to be and do for us. So I'm going to come back over here to the whiteboard. I'll move over here. And essentially, for each of these values, we can think of this as like a graph, okay? We're going to have a value over here on the y-axis and then a value here on the x-axis. So this is our y-axis, this is our x-axis. And let's talk bullet speed. So maybe our projectile speed is going to start right here with a y value of, I'm going to probably say 270. And then it's going to end all the way over here at a value of, I think 520. All right, now on the x-axis, we're going to have a value of 0 and then some arbitrary value of 1. And so I've got 2 points. We're going to start here. We want to start at 270. That's our starting point. And we want to end over here at 520. All right, so I have a starting point and an ending point. When the game starts, this is going to be the bullet speed, 270. All right, and when the game is at its max difficulty, this is going to be its speed, 520. And so now imagine there's going to be some line that exists between them. And what we're going to do is we are going to calculate some value. We're going to call it ramp. Our ramp value, which is going to be somewhere between 0 and 1. And so if it's 0, where are we going to be? Well, if it's 0, we're going to fall right here at this value. The bullet speed is going to be 270. And when it's 1, we're going to fall way up here. Our bullet speed is going to be 520. But imagine, as we play our game, we are going to increase the value of our ramp. So maybe after playing it for a while, it is 0.25. And when it's 0.25, we're going to be about a quarter of a way to the end of our ramp. And so our bullet speed is going to be clocked in right here. So I don't know, maybe this is like 340. And then as our ramp increases, maybe to about 0.5, that's going to be the midpoint. And I have no idea what the midpoint is of this interval, so I apologize because I'm probably going to be incorrect. Let's just say 410. And then maybe when it gets to be like 0.9, it's going to be right here. We're going to follow that line. And that's going to allow us to scale the difficulty of our game. Maybe now our bullets are moving at a speed of 500. So our ramp, we are going to set the ramp value, and we are going to set these minimum and maximum values, and then let the ramp do the work of scaling our difficulty. This is a process known as, I'll write it down so we have it here. It is a process known as linear interpolation. Interpolation. Now, because that's really a big word and a big pain to write, we call it lerp. All right. So we're going to use the lerp function to perform this mathematics for us. And so let's take a look at this. Let's minimize this. Let's put that math into practice. The first variable I have here for my ramp is how long do I want it to take to finish the ramp? How long do I want it to take to go from our starting values to our ending values? And so this is going to be in seconds. And so I'm going to pick 75 seconds. If you make it longer, it just means it's going to take longer for your gameplay to scale to its max values. If it's shorter, it's just going to take a shorter amount of time. Let's see, we've got projectile speed starts. Well, if we look, what do we want our projectiles to start at? Originally we were at 4.5 pixels per frame. So I'm going to multiply that by 60 frames per second. And that gives me a starting speed of 270 pixels per second. And then my ending speed at maximum difficulty, they're going to be moving 520 pixels per second. Just arbitrary values I picked. And we're also going to use our ramp to determine how many turrets should be on the battlefield. So when we start, I'll just say we got to start with 1 turret. And at our maximum difficulty, I'm going to have 5 turrets. All right, so our ramp values are done. And if I refresh the page now, are we using that new speed? Oh, look at that. Now we're back cooking, okay? But unfortunately right now, I don't think we are updating the bullet's speed at all, all right? So let's take a look. Let's head to mission number 5. Mission number 5 says we got to set the ramp constant. All right, so let's look right here. We already did mission 5. We're on mission 6. Look at us making progress. Mission number 6, we are now in this, sorry, my Alexa just started talking to me. We are now in this new update ramp values function. Remember, we were calling this right here in our draw function. So every frame of our game, we're going to update the ramp's values. So let's see. The first thing that we need to do in this function is we have to define what difficulty level our ramp is at. Remember, the ramp is going to be some number between 0 and 1. How are we going to calculate this? Well, the way we get this, we want a fraction that's going to be between 0 and 1. And so we're keeping track of, remember, runtime seconds. We're keeping track of how long the game has been running for. And we also have a variable called ramp time seconds, which is the time it should take for us to hit maximum difficulty. So I'm going to use a fraction here. I'm going to say, hey, ramp is equal to runtime seconds. That's how long the game has been running, divided by ramp time seconds. That's the time it should take for us to reach maximum difficulty. So when we start the game, this is 0. 0 divided by, 75, yep, is just 0. So our ramp is 0, and we begin right here at the beginning of our game. And when we hit 75 seconds, 75 divided by 75 is 1, so we're all the way over here at our maximum difficulty. But there becomes a problem here. What happens when we are at 80 seconds or 90 seconds? Well, 80 divided by 75, 90 divided by 75 is greater than 1, and so it puts us off this graph, which is not good. So what we need to do is we have to constrain this value. So I'm going to just highlight this and hit Control X to cut it. And let's call the constrain function. And what I want to constrain is that ratio right there. And we're going to constrain it between a minimum value of 0 and a maximum value of 1. Awesome. Mission 6 complete. Now, we are going to use this ramp right here in Mission 7 to do some lerp scaling. Remember, lerp means linear interpolation. It is going to allow us to take our starting value and our ending value and slowly have it follow this line. So our difficulty increases as our game moves on, nice and smoothly. All right, so how are we going to do this? We're going to use it for projectile speed. So if you remember, we introduced a variable called projectile speed. It's not a constant anymore. We defined it with let because we said we are going to be changing its value. We're going to change it basically every single second of our game. The bullets are going to be moving faster and faster and faster based on our ramp. So let's target that variable. Projectile speed is equal to, now we are going to use the lerp function to do linear interpolation. And when you do this, you have to give your starting value and your ending value. You have to give, let's go back over here. You got to give this point and this point. You got to give those values, right? You need to know this point and this point. Those 2 points are going to define our line for us. Thankfully, I have those in constants. I have projectile speed start, which is right here. And then I have projectile speed end, which is right there. And then you got to pass in a number between 0 and 1, right? So if you're at 0, it's going to put you right here at this point on the line. If it's 1, you're going to put it right here at this point on the line. If it is 0.5, it's going to put you smack dab in the middle. Thankfully, we have a variable that is constantly going to update its value based on how long the game has been played that lies between 0 and 1. It's our ramp value that we defined in mission number 6. So we will pass that in right there. And we have successfully done some linear interpolation. That's wonderful. If we run this, let's just see. Well, you know what? It's going to take 75 seconds for us to see the speed change of the bullet. That's way too long. Why don't we come back over here and let's go to mission 5 where we set our ramp constants. Let's just change the ramp time from 75 to 10 seconds. So now we're going to hit maximum difficulty at 10 seconds. Let's see if we see the bullets moving faster. All right, that's pretty slow. All right, let's see. They're not moving faster at all right now. They are still, maybe I did I click off of that? Yeah, I clicked off of that. Okay, I think I just didn't fully save this when I went to refresh it in the browser, because if I'm running it now, I do see that speed increase. So if we look here right at the start, the bullets are moving pretty slow. Now they're definitely moving faster. They're definitely moving faster. And if we really want to see it, what we can do is let's up the ending difficulty speed. I'll put it at like 1020. And so now if I run this, we're really going to see that speed increase followed by the ramp. Oh, oh, which, oh my goodness gracious. All right, so there, that ramp is working nicely. Now, one of the ways that I'm going to put this back to 520 because once we get lots of turrets going here, this is going to be a good speed for us. Now, we got one last mission that we should do, and that is going to be mission number 8. And the last thing we're going to do is we're going to display a readout here for our ramp. Because if like what I just had to do in order to verify that the speeds were actually updating was kind of a pain, right? I had to go through, and it's hard to visually see what's happening. I want data. I want numbers. And so we're going to have an optional sort of like debug tool for us that we're going to put just below the HUD, which is going to give us all of our values in our ramps. In our ramp. So we want to display the ramp readout. So this is, where are we? We're in our draw HUD function. We've got a lot of familiarity with this function. We draw everything that goes up in the HUD, our readout. And so if you look here, we're now drawing, hey look, we're drawing our time with runtime seconds. So that's right there. That's a new change. But if we scroll down a little bit, we got a function for our overdrive bar, and then we got a brand new function for our ramp readout, which is going to show us the ramp's value, our projectile speed, our number of active turrets as the ramp evolves. This function's already written. which is awesome. All I have to do is call it. So let's put right here, draw ramp readout, and 2 sets of parentheses to call it. And with that, I believe mission 8 is all done. A super simple mission to end on, but it's going to be really powerful because now we're going to see the ramp evolving in time. And there we have it. We start with 1 turret, our projectile speed. We're at 2 turrets, 3 turrets, 4 turrets. And now, when our game is at its maximum value after 5 seconds, look at that. Or I'm sorry, after 10 seconds, we got 5 turrets. We're at a speed of 520 pixels per second. Of course, we don't want our ramp to only be, 10 seconds long. Let's go back and change our ramp's time to be 75 seconds. At least that's what I'm going to choose to use. So now I'm going to see those values evolving much slower because the ramp is set to reach its maximum value in 75 seconds instead of 10 seconds. So you can see the speed going. Right now, we would be spawning a second turret when we implement that system. All right, bullets are starting to move faster and faster. And let's see, when would we spawn a third turret? Let's just see. Okay, let's see. There we go. And there our third turret would be coming in. Wonderful. I think this is a great place to stop. We did a lot of core behind the scenes work in our game here. We took our game, which was a frame-based system, and transitioned it to a time-based system. And that is such a huge performance improvement. This now means on any computer, slow or super fast, we're going to have consistent gameplay across those computers. And we put a system in place that is going to allow us to scale the difficulty of our game at the rate we want to in a smooth and controlled way. And that is our ramp, which operates with linear interpolation. I hope you found this video interesting, and I can't wait to continue with you in our next one. I'll see you then.